it is our midterm presentation. Our topic is gravitational pendulum.
My name is Chen Yuwen.
I am Huang Xueguan.
I'm Chen Chao.
I am Denaya Lepatei.
I am Yang Shun Yao.
My name is Yang Shun Yao, and now I'm going to talk about the evolution of the pendulum clock. In 3500 BC, the Egyptians used their obelisks to measure time with the shadow they projected. This is so far the earliest sundial recorded. In 1335, the first mechanical clock is built in Milan during the Renaissance. In 1583, by observing the swimming motion of chandelier in Pisa Cathedral, Galileo discovered that the times taken for a chandelier to swing back and forth are the same. And in 1602, he developed the idea that becomes the key to an useful pendulum, which is called isochronism. Christian Huygens is widely regarded as one of the most greatest physicists. He not only derived geometrically the now standard formula for the centripetal force, but he also proposed the conservation of the momentum. At that time, Huygens found that only when the swing angle is limited to small swings is the isochronism achieved. However, if the swing angle is really large, for example, when it is 60 degrees, strict isochronism cannot be expected. Huygens made a careful study and fixed those problems, and then he studied further about the application of pendulum in the clock's mechanism. In 1656, Huygens built the first pendulum clock, and it turned out that its accuracy was 100 times better than the timer that was used before. Then in 1930, the pendulum clock was replaced with electric clocks. Next, I would like to talk about the mechanism of the pendulum. The mechanism of pendulum contains three parts: isochronism, harmonic oscillator, and roller coaster. Isochronism means that the period or swing of a pendulum is approximately the same for different size swings. Meanwhile, a pendulum increases the accuracy of clocks enormously because of the harmonic oscillator. At last, roller coaster means that the energy in a pendulum is constantly swapping between potential and kinetic energy. Another issue that must be mentioned is the design barrier of a pendulum. First of all, considering the timekeeper's accuracy, pendulums have to be stationary. Any disturbance can affect the swing of the pendulum. Therefore, a pendulum's portability is decreased. Second, gravity. Even though we think of gravity as a constant, the strength with which Earth's gravitational force pulls on objects varies across the surface of our planet. Last but not least, the changes in the length that could be produced by temperature, like shrinking or expanding, will also affect the pendulum work.
Hi everyone, my name is Chen Yuwen. I'm now talking about the understanding and discover parts of our project. The physical phenomenon of our project includes pendulum, gravitational potential energy, frictional force, internal energy, and escapement system.
And then the extra is elasticity, but we haven't added it into our midterm presentation. We wanted to add it in our final presentation. We are going to replace the gravitational potential energy part with elasticity.
For a pendulum sign, we use Newton's law to divide this formula. Is second order theta over t plus g over length times sine theta equal to 0. For the period of this pendulum, we use period equal to 4 times root of length over g times k times sine initial theta over 2, and which k is elliptic integral. When the theta is far smaller than 1, sin theta will almost equal to theta, and the formula will from this one become to this one. For the gravitational potential energy, we use this formula is potential energy equal to mass times g times height. For the frictional force, we have two types of frictional force. One is static friction, another is kinetic friction. They have different constant and they all times normal force. For the internal energy, we have 4 items to construct the internal energy. First of all, the stack A will give B a force to push B up, and also gear D will give gear C a force letting it spin, and gear C will then give stick A a force letting the pendulum swinging continuously. For the escapement system, the escapement device will stabilize the whole system. If we remove the escapement device B, gear D and gear C will keep spinning because of the gravitational potential force that the free force item creates. The parameters of our project include mass and length. We use different mass of the object in the free force device and different lengths of the pendulum.
I am Hongshe Guan, and now I'm going to talk about the simulation using the Python code. And we are going to use the Python code to simulate 2 parts. The first part is the free fall simulation. And because we are going to import a module called vPython inside to create an animation to demonstrate what we want in the future. So first we are going to set the initial value. The size of the ball, we set it to be 1, and the height, and the gravitational acceleration. And the time, at first it is 0, and the dt is 0.001. And then we are going to set the screen for the animation. First, we will set a scene, and we call it canvas, and we set all the parameters needed inside. And then we are going to set a floor. We set it using a box, and these are the parameters we need. And we need a ball, and also we need a string since our device is a string attached to a ball. And then we are going to have other graphs that demonstrate the different changes in the displacement of y and the velocity. And this is our Python code. We let the velocity of the ball be the sum of the acceleration of the ball times dt, and the position will be the sum of the velocity of the ball times dt. And the arrow part is where we set the string to be, and the axis of the string is also the sum of the ball velocity times dt. And then later we are going to plot the displacement of the y and plot the velocity of the ball. So let's see our result. Oh, we cannot see this video. Okay, so this video is a simple demonstration of what our device will be like. It's just a part of our device, and we want it to be like a string attached to a ball and slowly coming down and gradually pulling the gear to spin. And the second one is the plot of the displacement of y and the velocity. And this one, we set the bold size to be 1. And the time is 1.68. And the second video, we set the bold size to be 0.1. And let's see the results. The time is 1.7. So the time took longer than the first one. And the third animation is we set the bowl. Wait, nope, that's the first one. That's the second one. And the third animation, we set the size of the bowl to be 2, making it heavier. And then we'll get a result with time of 1.62. That is slightly more than the first one when the size is 1 and more than the 0.1 size one. Yes. And then next we will invite another classmate to introduce the pendulum simulation.
Hello everyone, I'm Chen Chao. I'm going to introduce the pendulum simulation. So first we have a video. It is a model of pendulum simulation and also the change of energy. As the video shown, we will divide our code to 2 parts. One is to simulate the movement of pendulum. Another is to check the variation of velocity and displacement. So for the pendulum simulation, we use the same ways to displace the movement of pendulum, just as the free fall part. First, we have to set for initial value. M and size is the mass and radius of ball, and L is the length of string. Theta is the angle of swing, and below are gravity acceleration, period. Alpha is the angular acceleration. Omega is the angular velocity, and also time. Here is the same setting as previous part shot in free fall body. And we also setting the arrow of velocity. The last part is a code to draw the figure of simulation. This part is to calculate the torque, angular acceleration, angular velocity, and also angle of swing. And the next is the updating of the position, velocity, and also the length. Here is the updating of error of velocity, direction, and length. And this second part is to draw the figure of simulation. Third part is to check if the ball have gone through a period. The last part is updating the time. Here is a video of our result. And here is a track of omega, alpha, and theta. The blue one is a track of theta and the green one is a track of omega, and the red one is a track of alpha. And we make the Python to go through 5 periods. At the second part, we will focus on velocity and position. We know that the movement of simple pendulum will move according to second ordinary differential equation, as we mentioned before at the formula part. So, in this section, we will use ordinary differential equation to solve the movement. At the beginning is a setting for initial value and the solution using ODE to calculus. This is the initial condition of theta and time. Next, we make Python to plot out the figure and the label. The left side is a code to update our value, and for the right side is our result. The figure represents the variation of the velocity and displacement for different amplitude and time. And we will invite our next team member to introduce for the next part.
Hello everyone, I am Denaya Lopetei, and I am going to introduce the 3D animation of our pendulum clock. So what we want to achieve with this 3D model of the clock is to show how the pendulum clock is supposed to work in real life. We use a game engine based on C++ to make this animation. We can see the clock main mechanism working after the intervention of the free fall item. Hello everyone, I am Denaya Lopetei, and I am going to introduce the 3D animation of our pendulum clock. What we want to achieve with this 3D model of the clock is to show how this pendulum clock is supposed to work in real life. We use a game engine based on C++ to make this animation. We can see the clock main mechanism working after the intervention of the free fall item. What happens is that the clock is going to start working in the next order. First, the free fall item is going to give an impulse to the big gear in the middle of the mechanism. Once the big gear starts running, it will also make the other little gear start turning because of the gear mechanism. So right now, we have a gear mechanism working freely. For this moment, we fix the code to make the big gear start moving with an angular velocity equal to the impulse received by the free fall item. Then calculated the angular velocity of the smaller gear to make it give the first impulse to the pendulum. Now, to control this mechanism and make it work with a fixated period, we add two little components, one pendulum and one escapement device. We use the pendulum to establish a simple harmonic movement that produces a defined time period for the clock to generate the clock characteristic 1 second movement to count seconds, minutes, and hours. However, how do these two recent add devices work together? Easy. The pendulum acts as the period determiner. We can say that it guides the whole mechanism to its space, and the escapement device acts as a helper to the pendulum to make the gears continue to move after the initial impulse. After the initial impulse code has worked okay, we apply the harmonic movement to the pendulum with the help of the Euler-Kramer method by calculating the tilt of the pendulum and updating it every frame. As for the escapement device, we just check the angle tilt of the pendulum. If it is more than half the amplitude, it means we make the escapement device go up. with the impulse of the pendulum's applied weight. When this happens, the gears can freely turn without anything stopping them. However, when the pendulum gets to the amplitude limit, we make the escapement device fall with a tilt angle because one of his tips is a fixed point. This makes the gear's movement stop for a period of time that equals half the period of the pendulum. And that is how we generate the 1 second clock movement. Now that we got a glimpse of our clock project, we can move to the conclusion of the project.
Finally, if we have time, we will try to building this flying pendulum system, which is almost the same with the normal system. The object on this side will create gravitational energy and resulting in the pendulum intertwining with the two sticks on the side. And this will help the whole system running stably.
Above is our presentation about pendulum clock. Later we will 3D print our physical gravity clock, and we will change the length of the string, the mass of the ball. Besides, we will change from gravitational potential energy to elastic potential energy. And we will make a flying pendulum as an extra bonus, but we won't analyze it. Well, thank you for your listening.